again, is the last new identity that we're going to learn is sum and difference identities. Okay, so what we're looking at here is we're using U and V to represent two different angle measures. Okay, so if we're asked for a trig value of an angle that we don't know from the unit circle, but we can use angles that we do know to either add or subtract to that number, that's how we're going to utilize these most often, is to evaluate trig at angles that are not our special 30, 45, 60 that we have memorized on the unit circle. Okay, so if it is a sine of the sum or difference of two angles, okay, we can expand it to be sine of the first angle times cosine of the second angle, and then plus or minus whatever sine is here is going to be the same here. Cosine of the first angle times sine of the second angle. Okay, so sine and cosine look really similar. So I want to just point out some of the differences. Get to do this. So notice how they have sine of the first angle and sine of the second angle separated, as do they for cosine of the second and cosine of the first. Okay, so the cosines and sines are mixed together. You'll notice on the cosine expansion, the cosines are multiplied by each other. Cosine of the first angle times cosine of the second angle. And the sines are multiplied by each other. Sine of the first angle and sine of the second angle. The other thing that is different that should stand out to you is notice how this says plus or minus and this says minus or plus. That is intentional. Okay, this is reversed because it is the opposite sign that you see here. So if you're doing the cosine sum, when you actually expand it, it'll be a minus. Does that make sense? Up here for sine, it's plus minus plus minus. So this sign stays the same. If it's a plus here, it's a plus here. Now for tangent, you have both. So let me do the same in green. Okay, so it stays the same. Here it was opposite. So for, bless you, for tangent, you end up with a product on the bottom of tangent of the two angles. Okay, added or subtracted from one. And the sum of the tangent of both angles on top. So you have a fraction. And notice there's a plus or a minus in both the top and the bottom of the fraction. So in the numerator, you keep the same sign. And in the denominator, it's the opposite sign. Okay, so I would make a note or something that those in pink are opposite signs. Feel okay about how to interpret those? Those are the identities. That's what we're going to be using to do a few different types of questions. We're going to start with basic evaluation. And this is what is going to be the most common question using these that you're going to see. Okay, this is what I was saying. If you don't know the angle, it's not a memorized reference angle from the unit circle, but it can be broken down into one. We're going to be able to use sum and difference identities. So for instance, I don't have the 75-degree angle memorized on the unit circle to know what the ordered pair is. I don't imagine y'all do either. But are there two angles from the unit circle that would add together to equal 75? or subtract from each other to equal 75? What are they? Okay, so if I do a sum of 30 and 45, that would add to 75. So I could rewrite this. I could say, okay, I don't know cosine of 75, but I could do cosine of 30 plus 45. Because I do know cosine at both of those angles, right? So to expand this, let me kind of copy and paste this for us down here. So this one is cosine. We go. All right. So we can see that this is a plus when it's written. So this is a cosine sum formula. Cosine sum ID. Cosine sum formula. So cosine sum ID is what I'm going to use, which I'm going to take cosine of each of the angles. So cosine of 30 times cosine of 45. And then I'm going to do the opposite sign. So instead of a plus, I'm going to put minus. The opposite sign goes there. And then it's sine of both angles. So sine of 30 times sine of 45. So far, so good? It makes sense where everything's plugged in, how I wrote that? Okay, so you're just following the identity. You are not going to have to memorize this. You'll have this on a formula sheet. You just have to understand what gets plugged in where. Okay? So now I can evaluate this. So if you need to sketch a little image or two, do so to help you remember, or just look on your unit circle. Okay, so if I need to sketch my 45 and my 30 to help me recall the values there, at 45, what's the ordered pair? Y'all really should know your unit circle by this point. What's the ordered pair at 45 degrees? That's where they're the same, right? Root 2 over 2, root 2 over 2. Okay, what about at 30? It's root 3 over 2, 1/2. Remember, 30 starts with 3. So the root 3 over 2 comes first at 30. Okay, so these are the values that I'm going to write here. So cosine at 30, so remember cosine is the x or the y? The x. So cosine at 30 is root 3 over 2. Okay, cosine at 45 is root 2 over 2. Minus sine at 30, that's the 1/2. Times sine at 45 is also root 2 over 2. So some algebra you need to actually here. Let me do a little color coding here. So this cosine of 30 came from here. Sine of 30 came from there. sine of 45. And sine of 45. So that's where all those numbers came from. Is everybody okay with that? They came from the unit circle ordered pairs. Good? All right, so now we're going to evaluate. When you multiply radicals, you have to remember in math, you learned this, I don't know when, if it was algebra 1 or before, but when you multiply two radicals, as long as they're the same index, they're both a square root. It's not like one's a square root and one's a cube root. Okay, so they're both square roots. You get to multiply or divide what's underneath them. So this is multiplication. So square root of 3 times square root of 2 is square root of 6. Okay, 2 times 2 is 4. Okay, here 1 times root 2 is root 2. And 2 times 2 is 4. Hey, I'm subtracting fractions and I have a common denominator. That's nice. So I can go ahead and combine this. Okay, so it's all together over 4. That's my common denominator. That rule that I just said, when you're multiplying or dividing, you just multiply what's underneath the radical. That is not the same rule for adding or subtracting radicals. You do not add or subtract what's underneath. We would have to, because in your order of operations, you would take the radical because that's like a power of each of those, and then you would subtract those. So we're not going to simplify that any further. We're going to leave it as root 6 minus root 2, but together over 4 as a single fraction. Does that process make sense? Okay, pretty straightforward. You're going to use this the identity, and then you have to know your unit circle. So if you need to get out your unit circle to use as reference while we're doing this, you can. Just remember, as I mentioned to you, when we test over this, we're not going to give you a full complete unit circle. It will give you a full unit circle, but most of it's going to be blank. Only quadrant 1 will be filled in. You'll have to be able to fill in the rest of that. Okay, now this next one is sine. So I'm going to go ahead and copy down that image so we can use it. All right. Now, what's going to be a little trickier about this one is the fact that it's in radians instead of degrees. So I can't simply, in my head, it's not as easy for me to say, oh, is pi thirds plus pi fourths, pi twelfths, or something like that, like it will with just integer values, right? So I need to think about all of my special angles in terms of twelfths, because when you add or subtract fractions, you have to have a common denominator. So I'm just going to go through off to the side here and write my special angles. What is happening? Why is that highlighting everything? Okay, so pi sixths, pi fourths, pi thirds, and pi halves. Those are the main reference angles that we have memorized. And then pi, but we know pi is 180. You probably don't have to write that one down. If it was in terms of 12s, it would be 12 pi twelfths, right? If I want to change 1 pi sixth to a 12th, how many twelfths would that be? Good. 2 twelfths would be 1/6. Okay, what about fourths? How many twelfths would be 1/4? Okay, and how many thirds? And how many halves? 6. Very good. So here, now I can see them all in terms of twelfths. Is there any combination of those special angles that would add or subtract to give me 1 pi 12th? Not add. They're not going to add to get smaller. Yeah, I could subtract. I could rewrite this as sine of, okay, and then let me get a different color here. I could do 3/12 minus 2/12, or I could do 4/12 minus 3/12. Either one of those would get me to 1 pi 12th, wouldn't it? Okay, so which ones do y'all want to use? It'll work out the same with either. You'll get the same answer at the end. Okay, so we're going to use these two, okay, because we know that 4 pi 12ths minus 3 pi 12ths would give us the 1 pi 12th, right? Now, I'm not going to write it as 4 pi 12ths minus 3 pi 12ths. I'm going to use the angles how we are used to seeing them. So 4 pi 12ths is pi thirds. Bless you. And 3 pi 12ths is pi fourths. So that's how I'm going to replace pi 12ths with pi thirds minus pi fourths. Are we okay with that? So now that I've figured out what angles I'm using, now I can do what I did on the last one. And I'm going to plug everything into this identity. So I'm going to do sine of the first angle, which is the pi thirds. Now this is the one that mixes the two sine and cosine together. So then it's times cosine of the second angle, which is the pi fourths. And then this keeps the same sign, doesn't it? So this was a minus, so it's going to stay a minus. And then I'll have cosine of the first angle and sine of the second angle. Now, some people write these two in the other order. They keep it sine, cosine, but you just have to remember it's the opposite angle. That doesn't matter because when you multiply these two, does it matter like if it was 3 times 4 versus 4 times 3? No. Okay, so it doesn't matter if you switch the order of those. You just can't move them around the minus sign, but the ones that are being multiplied, you can switch the order if you wanted to. All right, so now I have to know those values. I have to know sine and cosine at pi thirds and pi fourths. So let me refresh my memory. Pi fourths, that's the 45, isn't it? That's the one we said is root 2 over 2, root 2 over 2. And then pi thirds, that's the 60-degree angle. So we hadn't looked at that point yet. That's the one that's reverse of the 30. So if 30 starts with 3, this one is flipped and it starts with the 1/2 and then the root 3 over 2. Okay, and I kept my sign the same here. Purple, blue. I'll do that again. Okay, so this is sine of pi fourths. That's going to go here. This is cosine of pi fourths. That's going to go here. Cosine of pi thirds will go here. Sine of pi thirds will go here. So that's going to be root 3 over 2 times root 2 over 2 minus 1/2 times the root 3 over 2. Oh, hang on. That's root 2 over 2. There we go. So again, that comes out to root 6 over 4 minus, and that comes out to root 2 over 4, which we can condense to root 6 minus root t all together over 4. Now look at that. We got the same answer for both of those. Does anybody know why? Their angle's not the same. Pi 12ths in degrees, what would that be? No, because if it's pi thirds, which is 60, and pi fourths, which is 45, 60 minus 45? 15. So this is a 15-degree angle. They're looking for sine. This was a 75-degree angle. They're looking for cosine. What do 75 and 15 add up to? 90. That means they're complementary, right? And remember how we talked about complementary angles? Like that's like the opposite acute angles in a right triangle. How their sine and cosine would be flipped. So cosine at 75 is the same as sine at 15. Cosine at 15 would be the same as sine at 75. Because the only thing that switches for sine and cosine is it's the opposite over the hypotenuse instead of the adjacent over the hypotenuse. And if these are complementary angles, those are like the opposite and adjacent sides of a right triangle, of the same right triangle. Does that make sense? That you didn't have to realize that, but that's an interesting connection that that's why they came out the same, because those two angles are complementary angles. All right. Let's see another way that we could use sum and difference identities. It says here, if a trig expression has the form of a sum or difference identity, you can use the identity to simplify an expression by rewriting the expression as a function of a single angle. Okay, so it's like we're condensing this instead of expanding it with the identity. Okay, so we're going to condense it down instead of this long expression because this is actually, this matches one of our identities. Notice how sine of each angle is together and cosine of each angle is together. So is this a cosine or a sine sum or difference identity when they're separated like that? That's cosine. So I know it's going to be cosine. Okay, now what are my two angles? What's my U and V? 25 and 15. Okay, and it's U and then V. So 25 and 15 are the two angles. Now, when it's cosine, should I do is it the same plus or minus here or the opposite? This is the opposite. So this actually needs to be a plus. So this is a cosine sum ID. Okay, so it's a sum here because we said that this needs to be the opposite of what's in the expanded version here. So cosine sum. Now, what is 25 plus 15? So they want us to write this as an expression of a function of a single angle. So I don't want to leave it like this because that's two angles. A single angle, we're going to go ahead and do that addition. So this is cosine of 40 degrees. Now it says in parentheses, and finding the exact value of that single angle in some cases. Not in this case, because 40 degrees is not one of the angles that we have memorized, right? That's not one of the special angles, so that I would just stop there. But on this next one, let's see, we've got our sines and cosines mixed together. So which identity form is this going to be? This one's going to be sine. Okay, and do you change the positive, negative, or leave it? So this is a difference. So this is the sine difference identity that we're going to use here. So it's sine, and the angles are 42 and 12. And we're doing the difference. So 42 minus 12. This one's in degrees. What is 42 minus 12? So should I stop here at sine of 30? Or is this the some cases they're referring to when I can give an exact value? Yeah, I know sine of 30. What is it? 1/2. You feel okay about going in that? I think that direction's a little easier, right? Okay. All right, now we've talked about simplifying and verifying with trig identities. So we're going to try doing that with the sum or difference identities. So simplify cosine of x minus 3 pi halves. All right, cosine difference identity. So this will expand to where the cosines and sines are separated, right? Like the cosines stick together and the sines stick together. So that's going to be cosine of x, cosine of 3 pi halves. And then do I switch the sign or does it stay the same for cosine? Switch it. So this is going to become plus, and then I have the sine of x, sine of 3 pi halves. Now 3 pi halves is a special angle, isn't it? Where's 3 pi halves? Yeah, right here. It's on the axis. There's 3 pi halves. What's the ordered pair there? 0, -1. So I'm going to remind myself that I did opposite sign here from that. And then I kept the sines together and I kept the cosines together. Now I'm going to do some substituting. Is 0 the cosine or the sine? Cosine of 3 pi halves, so that's going to go here. Okay, and this is the sine of 3 pi halves, so that's going to go here. I don't know cosine of x and sine of x. I can't do anything with that. It's a variable, an unknown. But that's 0. And that's -1. Well, what happens when you multiply by 0? You get 0. This whole term is just gone, isn't it? Y'all agree? That's 0. I don't even need to write 0. What happens when I multiply by a -1? Yeah, it just changes the sign. It was positive, so now it's negative sine of x. So I simplified that down to just negative sine of x. Do you feel okay about that? All right, now verify is the same concept, bless you, but remember it has the equal sign, so you know what you're working toward. So we're going to simplify this left side, and I know it should come out to tangent of x. So I just want to verify that. I want to show that work to prove that. Okay, so the tangent identity, we haven't done one with the tangent. Remember, this one, let me scroll back to the top to remind you. This is the one that's the fraction. So you're doing the sum or difference, depending on what sign is here, of the tangent of the two angles on top, and then 1 minus or plus the product of the tangents of the two angles. Okay, so that's what I'm going to use here. So my two angles are x and 3 pi. So I'm going to do the sum on the top, because again, this is a sum right here. So tangent of x plus tangent of 3 pi over, and then it's 1, and then it's the opposite sign. So this is going to be minus. And then it's the product of tangent of x, tangent of 3 pi. So I kept the sign the same in the numerator and the opposite in the denominator. All right, where is 3 pi? This is 0. This is pi. Yeah, 2 pi, 3 pi, right? So it's right here. What is the ordered pair there? -1, 0. So it's left 1, up or down 0. Now, the ordered pair is cosine sine. How do I get tangent there? Yeah, if you have it memorized, great. If you don't, it's always sine divided by cosine. So what's 0 divided by anything? 0. So tangent at 3 pi is 0. So I'm going to have tangent of x plus 0 and 1 minus tangent of x times 0. So we just got through saying anything times 0 is 0, isn't it? So that's just gone. Don't need it. So 1 minus 0 is just a 1, isn't it? If you have a 1 in your denominator, is that necessary to write? No. And in the top, if I add 0 to something, does it change it? So what's left in the top? Just tangent. So this is simply tangent of x. And for the sake of our notes, I'll show that it's now just over 1, which is just tangent of x, which is what I was trying to prove, isn't it? That's what I was verifying. Feel okay about that one? I'll highlight there too. I got tangent is 0 at 3 pi halves. So that's where the 0 came from, here and here. Good? All right, last but not least. This one's going to be back in degrees, and it is solving for x. Okay, so this goes back. So we did simplify, we did verify, now solve. So I want to actually know, what does x equal? So the easiest way to do this, I've got two different sum or difference IDs. Right here, that's a sine sum, isn't it? Sine of the sum of two angles. And this is a sine difference. Y'all agree? So I'm actually going to have to expand both of those. So I'll do one in one color and one in the other. So for the first one, x and 45, the sum. So remember, sine is the one that mixes together. So you do sine of x. And actually, did we? Yeah, that's fine. Okay. I showed that already. All right. So sine of x, cosine of 45. And then sine keeps the plus or minus the same. So that's going to be plus. And then it's going to be cosine of x, sine of 45. Okay. So that one I did in green. So that's that expansion. Is everybody cool with that? And then I've got this plus sign in the middle. I'll kind of separate these. Then let's do this one in purple here. Okay, so this is the same idea, except what's the only difference going to be? You're going to have a minus because this is a difference. So we had a sign sum, a sign difference. Oops, I didn't mean to circle that there. Circle it here. Okay, and this is all equal to -1. All right, I can drop all the parentheses, can't I? Because there's nothing to add or subtract in there. This is a plus, so if I were to distribute that plus, it wouldn't change anything, would it? Okay, so if you want to drop the parentheses, you can. I'll just erase them so I don't have to rewrite it all. Okay, so I don't need those now. Do you see anything that we can combine or that are like terms? Yeah, I've got sine of x, cosine of 45 twice, don't I? There's two of those. They're both positive. So I can combine those. I can write that as 2 cosine, or excuse me, that's sine first. 2 sine x cosine 45s. What else? Yep, they sure do. This one here is positive. See that plus? And this one here is negative of the exact same thing. So those cancel each other out. That's gone. That's a 0. So this is what I've got so far, equal to -1. You can go ahead and replace the cosine of 45 first, or you can divide the 2 over first. It really doesn't matter. In the end, you're going to get the same thing. What is cosine of 45? So if I do it this way, I can actually simplify a little bit over here. How's that? What can I simplify on the left side here? Yeah, I've got a 2 being multiplied and a 2 being divided in another factor. So those 2's reduce with each other. Over here. So now I've got square root of 2 times sine of x. Equal to -1. How can I get rid of that square root of 2? Yeah, I'm going to divide it over to the other side. So now I've got sine of x is -1 over root 2. We don't leave radicals in the denominator. Remember that we rationalize. So if I go to rationalize this, I get negative root 2 over 2. That should look familiar. Root 2 over 2 happens at 45-degree reference angles, doesn't it? Okay. Where is sine negative? In what quadrants is sine negative? Yeah, sine is negative down here. So I need to be looking at the 45-degree reference angles in these two quadrants. So what are those? Yeah, here in quadrant 3, that's 225. And what is that in quadrant 4? 315. So that's X. Those are the angles where sine is negative root 2 over 2. Does that make sense? So I kind of did a little bit of everything. We did some evaluating. We did some working backwards. We did simplify, verify, solve. Okay, so tomorrow you're going to have a chance to practice all of that. And you've got like at least one of each type of example to look back on. Yes. So no new homework tonight. Use tonight if you have time to keep playing catch up if you're behind on something or need to finish up quiz corrections. Okay, so no new assignment. Just try and get caught up on missing work or keep working on your corrections.